Good morning students. In today's class we are going to see the 8th experiment in op-amp and LIC lab. So it is design and realization of op-amp based function generator to generate sine, square and triangular wave at desired frequency. Main aim of the experiment is to design the circuit to generate square wave and triangular wave of the desired frequency. So without if you you can design the op-amp circuit to generate sine, square and triangular wave. Instead of using a signal generator, the design circuit can be used in that respective place. So the circuit diagram of the op-amp as a function generator. So first here integrator and differentiator circuit will be seeing. So this is the circuit that differentiates this input and it is your integrating part. So here we are not going to give any input, like just with the available voltage at its output it is going to generate the function. I just act like a stable multivibrator and the first part of the circuit, like this part of the circuit is going to be the stable multivibrator and this part of the circuit is going to act as a integrator. The design procedure for the stable multivibrator is T is equal to 2F RF into C, the anti-logarithm of 1 plus beta divided by 1 minus beta. So when you are going to consider the value of R1 as 1.16 times that of R2, T will be equal to 2 RF into C. So let us take the value of C as 0.1 microfarad, where the value of RF calculated is 4.7 kilo ohm. So in case of your integrator, you have to see to that the integrator time constant R3 into C1. So here the feedback is input is R3 and this is C1. So we need to see the time constant of R3 and C1. So the time constant of R3 and C1 should be very much larger than the value of T. So here we are going to assume the time as 10 milliseconds. For this, the calculated value of R and C is going to be, R is going to be 470 kilo ohm, R3 is 47 k and C1 is 0.22 microfarad. So according to the design value of R, C and for the corresponding frequency, the circuits are connected and the connections are given as per the circuit diagram, and the supplied voltage, that is plus VCC and minus VCC, is given as plus 12 volt and minus 12 volt. So it is going to be the expected output. So without giving any input, it is going to generate a square wave and triangular wave at its output, that is V01 and V02. V01 is the output of your stable multivibrator. So V01, it is the voltage available at this particular point. So it is going to be the stable multivibrator, and output V02 is going to be your triangular wave. So it is the output of your integrator circuit. Now the practical demonstration video of op-amp as function generator can be explained over here.
Circuit, as for the circuit diagram, the connections are given, and here we have given the dual power supply for biasing, plus VCC at pin number 7 and minus VE at pin number 4. Okay, so here the first op-amp, this first op-amp is act as a astable multivibrator. That is, the output of the astable multivibrator will be square waveform, and the second one will be the integrator. Okay, the integrator output will be the triangular waveform. If you integrate the square waveform, you will get the triangular waveform. But that is theoretical, but practically how the square waveform using
So the first part of the circuit is going to be the astable multivibrator. For in case of your astable multivibrator, a triangular wave, a square wave will be framed, and in case of your in case of your second part of the circuit is going to be the integrator circuit. So in that, the output waveform is going to be the triangular waveform, So here the astable multivibrator output will act as an input for the integrator circuit. When the square waveform is going to be integrated, then we will be getting the waveform as triangle as shown over here. So we can vary the value of the frequency by changing the value
so
of
that I have shown here. This is a triangular waveform from integrator and the square waveform from the this one skimmer trigger. Okay, thank you students.
So from CRO, the tabulated value is going to be the rectangular wave and the triangular wave. The rectangular wave is the output of your astable multivibrator and the triangular wave is the output of your integrated part. So this is how you can design the op-amp to generate the waveform, and also you can make it to work as a function generator. Thus the op-amp is realized as function generator using IC 741 to generate sine, square and triangular wave for the desired frequency. Thank you students.